In this video, we're going to take a look at the simplest way to test and run Lambda functions. We'll run tests locally without any complex emulation of AWS services or any unnecessary tools and abstractions. We'll run automated tests in GitHub Actions with minimal and easy configuration, and we'll run end-to-end integration tests of our Lambda functions before releasing them, and again with minimal setup. We'll try to keep everything as simple as possible. After all, the biggest benefit of Lambda functions is how simple they are. So we'll also look at the simplest way possible to test them. To see how to run tests, we'll look at a real example of a Lambda function. What the function is going to do is accept an argument as an input with a URL and a name, and then it will return an output, also an object, with an S3 URL and a title. First, download the website from the URL. So let's say we provide the URL github.com. So our function will download the HTML from GitHub. Then it will save this HTML to S3 with the file name that we provided. It will return to us the URL of the saved file on the S3 bucket. It will be called S3 URL. And finally, it will return the title of the website as a title argument. Let's see a demo of how this function works. This is the URL to our function, and we'll see how to set it up. And we pass it two arguments. First, the URL that we want to download, in this case github.com, and then the name of the file on S3, which is GitHub. After we run the function, we get, first of all, the link to the S3 file that we downloaded. Let's try to open it. And this is our S3 bucket, and this is the github.html file that we can see here. Also, it parsed the title from the HTML file. And this title is also returned from our function. So let's actually create our function and then start writing the code and the test for it. We'll create a new folder for our project. We'll call it lambda URL to HTML. And we'll start a new npm project. Since I'm going to use TypeScript in our example, I'm going to install a few type libraries. First, the types for AWS Lambda, types for Node.js, and then aws-build register, which will allow us to run TypeScript code from Node.js. Let's define the input object that our function will accept, and then also the output object, which it will return. Our input is going to have a URL and the name, which is going to be the name of the file that we saved to S3. And in return, we'll get the output, which will contain a title. We'll parse out the title from the HTML that we downloaded. And S3 URL, which is going to be the link to the file that we downloaded and saved to S3. Now let's also define the handler. Add the types for the event object and for the response. We'll also define a simple response from our function. All it needs is a status code. We'll say it's 200 for now. And a body, which will be our output object. And our body needs to be a string, so we'll stringify it. Let's create another file that we'll use to run this function locally. We'll call it run.ts, and what we'll do, we'll simply import our function, our handler, from the other file. We'll call this handler with an empty object, and then we'll simply print the results. So far, our Lambda function is just Node.js code with no dependencies. Let's execute it using Node. We'll run our run.ts file, which calls our handler. And since we're using TypeScript and not plain JavaScript, we'll pass the aws-build register library to it, which we installed earlier. By using the R flag and calling aws-build register, it will remove the TypeScript annotations and run the code for us. So far, it's very easy. Our Lambda has no dependencies, and we can simply use Node.js to run it. Let's quickly deploy our function to AWS. You can use any method you want to create and deploy the Lambda function. The simplest method is just to go to the AWS console and create a new function. Since our function is going to save files to S3, let's quickly add permissions to it. We'll go to Configuration, Permissions, and click the role name. And under Add Permissions, we'll attach the policy to write to S3. To keep it simple, we'll give it full access to our S3. And the second thing we're going to do is create an alias. I'm going to create an alias called live, and for now point it to the latest version. We'll see how to use this alias a bit later. So let's go back to the function. And now we need to somehow take our local Lambda function and push it to AWS. And again, here you can use any deployment method you like. I'm going to use a tool called lambda build. First, we'll install it globally. Using this tool, we can take our TypeScript file, bundle it, which means it will include all the npm dependencies if we had any, then create an archive and even upload it to AWS for us. So we'll use the upload command. Let's see how it works. So we need to specify the name of our function and then the region to which we want to deploy. In our case, the name of the function is lambda URL to HTML, and it's on the US East 2 region. By default, it will look for the index.js or TS file in our root folder. In our case, our handler is in that file. So we can simply run this command, and in just under a second, it bundled our function and pushed it to AWS. So if we'll go to the console and test our function, let's pass it just a simple object. We'll get our response, hello world, and URL goes here. So now we have a quick way to push our Lambda function. And to make it even easier, I'll go to package.json to scripts, and I'll create a new script that will execute this command for us. So now every time we want to deploy, we'll simply run npm run deploy. And our Lambda function will be bundled and uploaded. And back in the console, let's publish the first version of our function, version number 1. And to make it easier to work with versions, we'll go to the alias we created, which is called live, and we'll point it to version number 1. And now under the live alias, we'll also create a URL. Make sure to create this functional URL under the live alias, because we want our URL to point to this alias, and then this alias to point to the version we want to use. So we'll create a function URL. We don't want any authentication. And once our URL is created, we have a quick and easy way to run our Lambda function using the browser. So let's test it real quick. We'll go to our function. We'll fix our typo to hello world. We'll run npm run deploy, and then we'll make sure the live alias points to the new version. So we'll first of all publish a new version, version number 2. We'll go to our live alias, change it to version number 2, and then refresh, and our typo is fixed in the production function as well. Back in our function, let's install a few dependencies. We're going to install Axios to fetch the HTML and download it, and then cherio, which is sort of like in-memory jQuery, which will take the HTML that we downloaded and then parse out the title from this HTML page so we can return it to the user. Let's also wrap everything in a try-catch statement and reset the body of the output. The user is going to pass us the arguments through the URL. An API gateway will take this URL and then turn these arguments into a query string object. So this query string parameters object will contain the body of the request, the input. We expect this input to have a URL, and then let's take this URL and let's use Axios to download the HTML from this website. Now that we have the HTML of the website, let's parse it using cherio and extract the title of the page from this HTML text. We'll pass this title directly to our output object. Now our function should be able to load the HTML from the URL that we passed to it and then parse out the title. Let's deploy and test it out real quick, and then add the unit tests to test this function locally. Now when we run npm run deploy, lambda build is going to take Axios and cherio and insert it into our bundle. So we don't need to do it ourselves. It's also nice because if we had more npm libraries in here that we don't use, they won't be included. So only the npm libraries that we actually need will be included in our bundle and then archived and automatically uploaded to AWS for us. In order to make it easier to create a new version and then promote our live alias to it, I'm going to use a tool called Lambda Buddy. You can create a free account, and once you connect your AWS account, you will see the list of all of your Lambda functions. To add a new version, you click this plus button over here, and version number 3 is created for us. And as you can see, the live alias is currently pointing to version number 2, but we can switch it to point to version number 3. And now if we go back to our Lambda function, let's give it a URL. The URL we'll give it will be Y Combinator, so it should return Hacker News as the title for us. And the title is returned as expected. We're finally ready to start writing unit tests for a function. Let's install the testing library that we're going to use, mocha, and sinon, which we're going to use as well, and their types. We'll also create a folder to hold our tests. We'll call it test, and an index.ts file for the code. So in our test folder, let's write the first test. We're going to use mocha for our tests. We also want to import the input, output, and the handler from our index file, because we're going to call this handler directly. The execute lambda function is going to help us with the tests. It's pretty much similar to our run file. All it does is calls the handler of our lambda function. We're going to specify only the attributes that we actually use. In our case, it's query string parameters. So we'll pass it the URL and the name, and this will allow us to easily call our lambda function locally. So when calling execute lambda, we'll just pass these two arguments and it will run our lambda function as if it's being called from API gateway. And as needed, we can also add other attributes. For example, the method of the request. If it was something that we're using in a lambda function, we can specify the method or the path or anything else in here. Then since API gateway returns the body of the response as a string instead of a JSON, we're going to parse it and return it from our execute lambda function as an object. So this is a utility helper function that we're going to use in our test to execute our lambda function. We're now ready to write our actual tests. Let's add two tests. The first one is for a use case in which it should get the HTML from a URL. And second one, it should extract and return the page title of a URL. So in both cases, we're going to call the execute lambda function and pass it different arguments and then check the response. In the first test, let's call our lambda function with the URL to example.com. And for now, we'll give it an empty name. Let's print the result to console and check it out. In the same way we ran our Node.js code using is-build-register, we're also going to use the same library for running our tests using mocha. So this is going to be our test command. First, it specifies the test folder, which will contain our tests. We only want to test files with a TS extension, and we're going to require is-build-register here as well. And now by simply running npm test, we can run our tests. In our first test, we got example domain back, and that's the actual title of this website. So our test actually made a network request to this website and got the URL from it. And while it worked in this case, it's not ideal that our test will make network requests, because we don't want to rely on the network and on an external website for our test to run. So we want to add a way to keep our request exactly as it is now, but instead of going to this website and actually downloading the HTML, we want to use fake HTML and just specify what kind of a result we're expecting when our lambda function calls this URL. And for that, we're going to use a library called sinon. Using sinon, we can create something called a stub. And basically, it will let us modify the axios object, and we can specify that when someone makes a GET request using axios while running the test, we can hijack that request and return any result that we want. So let's see how it works. We're going to use the stub function from sinon. By the way, if you learned something from this video, I would really appreciate it if you leave it a like so it could reach more people. We're going to pass it the axios library, which we loaded here from Axios. And now we can specify any of the methods that Axios implements. In our case, it's get. And since this function returns a promise, we can call the resolves function on sinon. And in here, we can specify exactly what our Axios get function returns. And we know that it returns an object with a data attribute, and this data attribute contains the HTML of the website that we passed as the URL. So let's give it some fake HTML. Our HTML is going to be very simple and just specify this title, which is hello world. When we execute our test now, instead of actually going to example.com, it should hijack this request and then return this HTML instead. So if everything works correctly, we should get the hello world title back in this output object. So let's try it out. It seems to be working, and in our case now, there was no network request. Even if we didn't have an internet connection, our test would still work. That's because we created the stub that hijacked the request and returned the value that we want. Instead of logging the response to the console, let's confirm that it's the value that we expect it to be. I've created this variable for our title, which will be the string that we also return from our HTML. So instead of logging to the console, let's use strict equal to make sure that the value that we get from output is equal to the title that we specify. Now we have this one passing test that doesn't make a network request, but does a good job of testing the logic of our function. So if we'll go back to our function, when we're running it, we actually make the same request to Axios. We didn't need to change our function at all. But by using the stub, we can pass any HTML we want to be returned from this axios.get call. And then we analyze it as if it's a real network request. So we were able to write this unit test without any complex tools or emulation. but our function is also supposed to save the HTML that we download to S3. So let's add this logic in our function and then add a unit test to work with it without actually using the S3 service. Because again, if we'll actually use S3, we'll need a dedicated bucket just for these tests, and it will also work slowly and we'll need to configure the credentials for this S3 bucket. We'll try to find a way using just Node.js to test this logic of our Lambda function and test the code that communicates with our S3 bucket. To work with S3, we're going to install the aws-sdk S3 client. This is going to be the code that we'll use to save files to S3. We'll initiate the S3 client, and this is how our bucket is going to be called. And we'll create a new object called storage, which only has one function. And this function takes the content of the file that we want to save and the name of this file, and then uses the put object command that we import from S3 to save the file to our bucket. After we save the file, we're going to return a string that contains the URL to the file that we just saved. Using this new function, we can modify our handler to save the downloaded file to S3 and return the URL to this new file. We're passing our store HTML file two arguments. The first one is the content of the file that we want to save, and the second one is the name that we got from the user, and this name contains the file name. Before we even create the bucket or try this out on a production environment, let's create our unit test. We'll use the exact same method using sinon and a stub. We'll create another stub, and this time we'll use the storage object which we created. It's pretty cool that the autocomplete already shows us the only function that this object has. And this function is supposed to be resolved with the string that contains the URL to the S3 file that we created. So we'll create a variable that will hold it, and we'll tell our new stub to be resolved with this file name. So now our output is supposed to have another attribute, the S3 file URL, and it should be equal to the S3 URL file variable that we created. Let's try to run it. As you can see, our code runs even though we didn't create the bucket yet. We were able to easily test our code by creating a stub and testing the actual logic of our function. For the context of our unit test, we only test the logic that accepts the URL from the user, passes it to S3, and then returns the path to the URL of the file that is created. Let's actually create the bucket now and then deploy our function and run it in production. In the S3 console, we'll click the Create Bucket button. For the bucket name, we're going to use lambda URL to HTML storage. And before I forget, I'll also update the code to use the same name. Now that our bucket was created, let's update the permissions to allow files to be public. We'll allow our bucket to set public permissions. And in the policy, we can go to policy examples and find the example in which it allows granting read-only permissions to an anonymous user. We'll simply copy this policy and then go back to our bucket and change it to our bucket name. This way, any file that we save on our bucket will be accessible publicly and we'll be able to open the URL that we returned from our Lambda function. Let's now deploy the latest version of our code to our Lambda function. We deployed our code using lambda build, and on lambda body we can create a new version first and then promote this version to be the latest one. Now we're ready to test our function. When we refresh now, we're supposed to see also the S3 URL, and we're also supposed to see the new file saved to our bucket. The file name appears as undefined because I forgot to add the file name to the list of arguments. Now it seems to work. First, let's test our new file. We'll copy this S3 URL and open it. And you can see the HTML that was saved from this website. And now if we'll go back to our bucket and to objects, we'll reload and we'll see this hnews file that we downloaded. Let's reorganize our tests a bit. Since we recreate the stubs in both of the tests, we need to reset them between the tests. And for that, we're going to call the after each function, which we import from mocha, and pass it the restore function, which we import from sinon. This way, after each of the tests runs, the stubs will be reset. Also, when creating a stub, we can save it in a variable, and then we can use this variable to make sure that our stub was first of all called one time only, and second, that the arguments that we pass to our stub are the same as we expect. We have two tests to test our lambda function, And now let's automate this. We'll create a GitHub repository and we'll create a GitHub action. So every time we push changes to our GitHub repository, our unit tests will run automatically for our lambda function. And also we'll configure our GitHub action to push the changes that we made to AWS. First, I created a repository for our lambda function on GitHub. To create a GitHub action for a repository, we'll need to add a folder with the preset name .github. And under this folder, we'll create another folder called workflows. And this is where we'll place our GitHub action YAML file. This is how our workflow GitHub action will look like. We'll define that it will be executed on every push, and then we'll define the continuous integration job. We'll run it on the latest version of Ubuntu. It will check out a repository and set up Node.js, and we'll specify Node version 16 because currently this is the version that we run our function on. Then we'll install our dependencies, and finally we'll run our test command. Since our tests don't rely on S3 or any network access, they'll first of all run quickly and we don't need to configure them, because the only thing we need to run our test is Node.js. Now we can simply push our code to GitHub and it will execute our test. Let's do that first, and afterwards we'll also add a command here so it will also deploy our function to AWS. So that every time we push code to our GitHub repository and the test will pass, it will also deploy our code. Once we push our code, GitHub will start executing our action. We can check out the results and see that both of our tests are running and passing. So let's add the command that will also push our changes to AWS. In order to push our changes, we'll also need to add the deploy command, which we already set up earlier using lambda build. To run it, we'll execute npm run deploy. But now we also need to specify our AWS keys. So lambda build will have the credentials to push our changes to our AWS account. And AWS provides a solution for this specific use case. It's open source under the AWS Actions organization. To use this action, we'll copy the example. And we'll also need to configure the secrets in our repository, because we need to provide it with the AWS access key ID and the secret access key. And we can do that by going to settings and then secrets, actions, and setting up 2 repository secrets. Once we add both the access key ID and the secret access key, we can now push our changes. Lambda build should now be able to pick up these credentials and push the changes to our AWS account. We also need to install lambda build locally, because earlier we installed it globally only, but to be able to run it on GitHub Actions, we need it installed as part of the repository. Let's see if our action works and whether it will succeed to push our code changes to our AWS account. And it seems to be working. Now it runs our tests, we can see here, and then it also deploys our function. You can see the output from lambda build here. First it created our bundle, it uses the region we specified, and then it pushed it to AWS. And now in lambda body we can create a new version and then point our alias to this new version. Let's make a small code change and test our new workflow. In the lambda handler, let's add some validation to make sure that the user passed the URL and the name arguments as we expect. And if not, then we'll return an error back. So first, we'll modify our output to also include an error. By default, we'll set the error to an empty string. And then also, if we catch an error in our catch statement, we'll add it to our output. We'll also add a very basic test to make sure that the user passed the arguments we expect. We'll simply check if the user didn't provide a name or didn't provide a URL, then we'll return the error as the response. First we'll throw the error and then we'll catch it over here and we'll add it to our output. And then also if an error is thrown from our code, then it will also be returned back to the user so they'll know what to fix. Let's test our workflow and see if now after we push the changes, they're automatically deployed to AWS. It seems like we have an issue now. Let's try to check the results of our action and see what broke. So it seems like one of our tests is breaking. The second test seems to be running fine, but the first test breaks. So let's fix it. The issue is that in the first test, we don't pass a name. And that's why our handler throws an error and our S3 URL attribute is empty. Let's put this name variable in the global scope. So the first test will also be able to use it. And then we'll pass it as a second argument. Now both tests should be okay, and let's push our changes. Our action works now, we fixed the tests, and now our code is being deployed to AWS. Even though lambda build pushed our latest code to AWS, it is still not released to production. And we have full control over that. We can now create a new version Version number 6 now checks that the user provided the correct arguments. But since we didn't point the live alias to it yet, we're still running version number 5 in production. So if we'll go to our lambda function and remove the URL and the name and try to run it, it still doesn't show us the error. But if we'll go back to lambda body and point the live alias to version number 6, and we'll try to refresh now, we can see the error that we added. And actually, the entire body object is not even defined. So we also need to make sure that the body itself is defined. But in any case, we now run the 6th version. However, we can also go back very easily to the 5th version. And now if we refresh, we won't have this error anymore because we run an older version. So using lambda body, we can very quickly go back and forth between all of the versions we deployed. It's very convenient that first of all, the deployment is so quick, and second, that we have all the previous versions and we can quickly change to any of them. So if something breaks in production, we can quickly go back to any version we want. If I'll point it to the 6th version, then we'll get the old error message, and I can always go back to the 7th version. We can also point our live alias to the latest version. And this way, any changes that we make and any code that we push will automatically be released to production and reflected in our production environment. So this is a very convenient option for development where you don't need to control exactly which version runs in production. But once you start releasing the app and you have actual users, it's of course safer to make the releases manually, make sure that nothing breaks, and have the option to quickly roll back to any version in the past. We can also use lambda body as a quick way to run end-to-end tests. For each lambda function that we have, we can also configure a set of tests and then run them for each one of the versions or when we release a new version. This way, before promoting our live alias to a new version, we can first confirm that our tests pass. Let's see how it works. If we click on the lambda function and go to the lambda functions page, if we scroll down, we can configure a test. So let's create a test to make sure that the validation of the arguments we added works as expected. For the body, we'll pass the JavaScript object that we want to pass to our lambda function. In our case, we want to pass an invalid argument. So instead of passing the URL and the name, we'll pass some argument that we don't expect. We'll also provide the expected result. Since we didn't provide a name and a URL, we expect our lambda function to return the error message that we added. Since we stringify our response, the body will be a string that contains JSON, and the error attribute will be equal to the error that we defined in our code. Create a test, and we'll add another test. We'll call it example.com. This time in the request body, we'll pass a URL and a name. Since our lambda function expects an API gateway event, we'll pass the same object that API gateway would pass with the query string parameters object. And it will contain the URL and the name that API gateway gets from the URL. For the expected result, let's actually try out our lambda function with these two arguments and see what kind of a response we get. I'm going to run the function with the URL pointing to example.com and then e2e_test as the file name for S3. These are the values that we can expect from our lambda for the title and for S3 URL. And this will be the object that our lambda function actually returns. We'll have the status code and a body, and the body will be a stringified JSON. And in that string, we can see that this JSON has a title, example domain, and an S3 URL. So this end-to-end test will actually run in production. We'll run it on our already deployed lambda function, and our function will actually call this example.com domain and save the e2e test file to S3. This will be our sort of a smoke test that will make sure that our lambda function works and has the correct permissions. And then every time we release a new version, our test will run and we'll know that we didn't break anything. Now that we have two tests, we can trigger them for each one of our versions. First, let's try to run them on our current version number 7. For our current version, both of our tests pass. Let's try to also run them on our previous version where we didn't have the error attribute. In this case, both of our tests fail, because in both of our expected responses we have an error attribute, and in this version we didn't add it yet. From now on, if we push a new version of our lambda function, then our tests will automatically run and notify us if everything works as we expect or if something breaks now that we should pay attention to. If you learned something from this video, I would really appreciate it if you can leave it a like so it will reach more people. Also, don't forget to subscribe to this channel because a lot of similar videos about Lambda and AWS are coming soon.